Okay, so again, we start on page 47. Welcome back. I hope we had a great long weekend. Before we jump into the material, we'll take a look at our calendar. Today, we are talking about in-context linear problems. I just want to highlight right here at the start that the material for this is completely in the packet. So tonight's homework is not going to be in the textbook. It'll be in the packet itself, okay? So it's a little bit different than usual. Next class is a catch-up day. I bet some of us are really looking forward to a catch-up day. I have no plan for Friday. We're just going to come in and catch up on whatever we feel like we're struggling with, all right? So you're going to do a lot of work with your groups. There are sample test problems you can start taking a look at, old homeworks, whatever you want to look at on Friday, we'll look at, okay? It'll be a moment for us to kind of catch our breaths. And then on the 25th, which is Monday, is quest number 2, all right? Quest number 2 is coming up this Monday. It's on classes 6 through 11. So here to here, this material. Any questions on the schedule? Everybody has the updated one, right? I had to reprint it because of the snow day. Anybody need it? I do have extras. For the calendar, I reprinted this and handed it out after the snow day. I have a few more here in case anybody needs. There you go. There you go. Anybody else? I gave this out a while back. Okay, so let's go ahead and jump in here on page 47, and we'll start here in the middle with number 1. Let's see, can we go to Glenn? Okay, thank you, Melanie. Okay, so lots of information in this problem, but I'm going to give you a hint here. You want to try to just find the 2 data points that are given to you. There's going to be 2 pairs of numbers given to you in this problem. And so I'm just going to highlight in yellow one pair. In 2009, what happened? 215 million bucks. So I'm going to highlight those in yellow. And then what's the next pair? In 2005, 28 million, okay? So pretty much everything in that long paragraph boils down to 2 pairs of numbers. And once we have 2 pairs of numbers, we start thinking of them like X's and Y's, like ordered pairs, then we can do all the linear stuff we've been doing. So let's try part A. Define the 2 variables for this situation, identify which is independent and which is dependent, including units. Now I know we had that kind of cutesy Johnny Depp thing. That only helps if you have the equation given to you, and the equation is the goal here. So we don't have an equation. So I don't think we can use the Johnny Depp thing. We really want to think about which one of these quantities depends on the other one. So first we're going to write down, I don't know which is which yet, so I'm just going to write them down below. I have 2009 and 2005. What's a good word for what we're measuring with those 2 numbers? Years, time. So one of them is going to be time in years. Put it down at the bottom because I don't know which one it is yet. And then the other numbers, the 215 million and the 28 million they are dollars, so those are the units. What are they measuring? Yeah, millions of dollars are the units. Yeah, sales. I mean, the only word here is the breathalyzer market. So we'll say sales in millions of dollars. So we've got our variables and we've got the units. And now we just have to pick which one we feel is the independent and which one is the dependent. So here are your 2 choices. The time depends on how much money, or the amount of money depends on the time. Which one do you feel is more natural? A few people saying money depending on time. Other thoughts? Yeah, I think that's the right way to think of it. Time is passing. Time doesn't care at all about the breathalyzer market, right? Time is passing independent of everything else, and as a result of time passing, there are changes in the breathalyzer market. So I think that it's probably a good rule of thumb to say if time is in the problem, which one is it? It's the independent. So we're going to put time in years there. And then the sales depends on the year. Okay, so I'll say it again. If time is in the problem, it's the independent variable. Okay, let's go to the next page. Part B, can we go to Adam? Okay, thank you. So I'm going to put up here X comma Y. That's my standard order. In this case, we don't have those letters. We have different letters. We have different things. But which one is the dependent variable for X or Y? Which one is dependent? Yeah, it's always the Y. So that's the default. Independent is first. Dependent is second. So if I believe that default, then I'm ready to put money and time up here in some order. So which one goes first? So time we said was independent. So we'll put that first because time is the independent one is first. And then I'll put over here the sales. So that's what my ordered pairs are going to look like. It's going to be the time, and then it's going to be the sales. Okay, I'm going to write something, and I'm going to encourage you not to copy it because I'm going to change this in a second. But what's the first time that's given to us? 2000 what? 2009, and what were the sales? 215 million. I'm not going to put the millions. I'll just leave it like that. So it's totally fine to translate the information into that point. But the X value is 2009, which is a really big number. Like it's literally 2009. So it's really common to kind of get rid of, come on in. It's really common to get rid of some of the bigness of the year numbers. Any suggestions for what we might do instead of 2009? How about just 09, right? And then we'll define that thing to be years since 2000. So that's the standard thing to do, is to pick something so you don't have these huge, huge years here. So maybe we'll just say 9 and 215. You can write that down. And then what was the other year? 2005. So what goes here? 5. And then the sales were, was it 28? I just think it's going to be easier to do the calculations with 9 than with 2009. Which also means we need to update because the thing we wrote on the last page is now wrong. So at the very bottom here, I said time was in years. I need to add what? Since 2000. Time in years since 2000. Okay, so we've now got our two ordered pairs, 9, 215, 5, 28. We're going to go over here to part C. It says label the axes and then plot the two ordered pairs. So is this a good idea or a bad idea? 1, 2, 3, 4, 5. Why is that bad? Yeah. What are we trying to get to on the y-axis here? Trying to get to 215. So you better make sure you get up to at least 215. So you can go by 5s if you think that's enough, 10s, 20s, 50s. You want to try to find a good balance. If I go by hundreds, then this number right here is 100. This number here is 200. And then 215 is, pretty much right down there. And all of a sudden the entire graph is there. That's not so good. So you got to find a good balance point. So I don't know how many boxes are here. It's not so important to count them all, but what do you think? Fives? If we go by fives, will we get there? Maybe tens? Okay, so tens might be close. We'll give a quick count. 1, 2, 3, 4. Yeah, I think tens will get us there. Right now I'm looking at this line. I think that's the 100 line if I go by tens. So just looking at the graph, I feel like that's a good measure. Go by tens. So I'm not going to write all the numbers in there. You can put as many as you feel like. I'm just going to write every few of them. So let's see, 10, 20. Maybe I'll write every 20. You could also write every 50. Yeah, so you can label them however you wish. And once we've got the vertical labeled, we can then label the horizontal. What are the horizontal numbers? Yeah, they're years. And what are the two X's that we're going to be plotting? 5 and 9. So you just got to pick a good scale so that 5 and 9 are here. They need to fit on here, but you don't want them to be smushed. Should I go by tens again? Now, if we go by tens, then this very first one here is a 10. And again, everything is compact. Everything happens before that line. So you can go by ones if you want. You can go by halves if you want. But you just want it so that the graph kind of has some space. So we'll go by halves or by ones? What do you want to do? By halves? Okay, so we'll go by halves. So that means that every other one is a new number. Okay. And once you've got the lines labeled, go ahead and plot the two dots. And I like to label the points right as soon as I'm plotting them. I don't know if we'll use those numbers, but easy enough to label. And then everything we've done so far this term has been straight lines. So go ahead and connect the dots with a straight line. Okay. And once we've got that done, I think this problem we can now ignore everything about the breathalyzer sales and everything about time. This is just an ordinary problem from here on out. The next part in D says write the equation that contains those 2 points. So we're trying to find the equation of that green line. This is an ordinary XY problem now that we've done the translating. So what's the first thing we need to find the equation of a line? It's slope. So let's go ahead and find the slope. Upstairs, is it the X's or the Y's? It's the Y's. So 215 minus 28 over 9 minus 5. So I got 187 over 4. Did I do that right? It's okay to switch them, but if you switch, then you better have switched both. So then you had a negative upstairs and downstairs? Yeah. So we can just do the division on the calculator. We'll get a decimal here. Thank you. Okay, so that's the slope, 46.75. Generally speaking, as a math teacher, I prefer fractions over decimals. But in terms of any kind of application, like a word problem like this, decimals mean a whole lot more. Money does not happen in fraction form. Money happens in dollars and cents, in decimals. Okay, so we've got the slope. Let's go ahead and continue now. We need the equation of the line. So I'm going to write my mx plus b version here. And then we're just going to start replacing. 3 of these letters are about to become numbers. Instead of y, how about we pick the second point? The numbers are a little smaller. So instead of y, 28 equals, instead of m, instead of x, pick the same point, so that's times 5, and then plus the b, which you're about to find. So do some work and solve that equation for b. So any questions on getting b is negative 205.75? Okay, and then we'll write our equation. I've run out of space, so I'm just going to go into the next line here. So the equation is this one. What do we do with y when we're writing our final equation? Leave it. It's just y. M, still 4675. X is x, plus b, minus 205.75. That right there is the equation of the green line. One little detail, it doesn't say don't use x and y in this problem, but on the quests coming up and on the test coming up, you can expect that I'm going to say don't use x and y. I'd rather we use letters that are more appropriate for this one. What was x representing again? It was time in years, so maybe t for time. So how about instead of x? So I'm going to write over here the word better, although it wasn't clear in these directions that you weren't allowed to use x and y. So better than that. Instead of x, we said that was time. So this would be a 4675 t minus 205.75. What was y measuring? Was the sales. S. S for sales. I just think it's more clear what the thing represents. X and Y are pretty meaningless in this problem. But S and T, I have some understanding of what they represent. Katrina. Yeah, I think it's totally fine, and that's what we did here. It's totally fine. We're comfortable with X and Y, so do everything with X and Y, but then at the end, let's go to these letters that mean a little bit more, like S and T. Yeah, I think that's full credit. Okay, part E, interpret the meaning of the slope in this context. Write a sentence in plain English. Okay, so first things first, I gotta make it really clear that when I say write a sentence in plain English that interprets the slope, that the number 4675 is in the sentence. I'm not looking for some generic slope represents a rate of change. I'm looking for what does 46.75 represent. So make sure the number is in the sentence. I've said this before, but to try to figure out what slope represents, for me, I got to write the units. So I'm going to go back up here to the slope calculation. We did it up here in black. Upstairs was 215 minus 28. What were the units? It was dollars. So I'm just going to put dollars over here. It was actually millions of dollars, right? Okay. 9 and 5, what were the units? That was years, so time measured in years. So just by writing that, I feel like I've got a good sense at least slope is dollars per year. Just look at it, dollars per year. Okay, the slope was 46.75. That means that the sales were increasing by $46.75 per year. So that's going to be my sentence down here. Sales were increasing by 46.75, and this is the only place I'll put the word millions of dollars per year. Absolutely. And if I say interpret the y-intercept, I want that number in the sentence. Yeah. How did I know it was increasing and not decreasing? The slope was positive, so I used the fact that that was a positive 46. I changed that word into increasing. Positive became increasing. Questions on this? And once you play this game enough to write down an interpretation for the slope, you start to see it's the same thing over and over again. The only things that change here are like what it is it's actually increasing or decreasing. It's always the y value. I'll say it again. The thing that's increasing or decreasing is always the y value. What was the y in this case? It was sales. There was another problem we did where we had the altitude of a balloon. You guys remember this one? There was a balloon that was coming down for a landing. This over here was altitude, and over here, no surprise, time. Time is there. That's right. So when we talk about slope, the thing that's changing is the y. What's the y in the balloon example? Is the altitude. So the altitude would have been decreasing by 800 feet per second. The game is always the same with the slope. It's always the y. That's the thing that goes first. In this case, it's sales. It could be altitude. All right, part F. Predict the value of personal breathalyzers that the model predicts will be sold this year, 2013, and interpret your solution by writing a complete sentence. So I'm going to start putting some arrows in here. So this is actually the answer to part E. And I'm going to squeeze in down here the answer to part F. So that 2013, is that the X value or the Y value? That's the X, right? It's on the horizontal. That's where the time was. And I'm plugging 2013 in for the X. What am I plugging in for the X? Just the 13. It would be consistent. So this problem is really just saying, plug in, and I'll put T equals 13 instead of X. So we go to our final equation from before, and we'll use it right now. I think it's something around 400. 402? Exactly 402? Okay. All right, 400 was a pretty good estimate, no? It's good. And then the final part of that one is to write a sentence. So see if you can write a sentence. Your sentence had better include two numbers, 2013, 402. For any sentence that you write, you just have to get across in 2013, we're projecting that the breathalyzer market will be 402 million. Right? And it's fine to use the word about or approximately. Certainly it's a guess. Nobody in the world knows what the right answer is to this problem. It hasn't happened yet, but that's our best estimate. It's okay if you don't use the word estimate in it. It's fine. Any questions on the sentence? Okay, there's an example here about dairy farms, but I think that we captured everything I was after in that first problem. So how about we have lots of time now. We have about 42 minutes to do the group activity. There are 3 big problems in the group activity. So let's see how far we can get on these right now. And let me just be really clear again, because the homework is in an unusual place today. So this is what you're working on for the next 40 minutes. If you go a couple of pages down the road, you will find an answer key. If you go past that, can everybody jump to page 52? So on page 52, take a look at the homework. The first thing here says complete the group activity, which is the stuff that we just passed over. So you're going to do that in the next 40 minutes. And then the thing that I'm actually going to collect are the problems that say for homework. They're right down here in the middle of the page. Everybody see it? It's confusing because it's the same exact title, in context linear problems, in context linear problems. Almost exactly the same. But this one says for homework. The ones you guys are going to do right now are the practice. Good? Okay, raise the flag if you get stuck. Go back a couple of pages and let's see how far we can get.